This next objective is showing you how simplifying radicals can be used in a real-world example. So for example, Pythagorean theorem, this is something that you've been doing in classes for a really long time. It's that the hypotenuse squared is equal to the sum of the squares of the other two legs of a 90-degree triangle. And so this is something that's used a lot in building and engineering, and the rule is that if you give a rounded answer, that rounded answer can be affected in data later on. And so what we want to do in math is keep things as exact as possible, but also with the ability to simplify. So for example, if I ask you to solve for side C in this right triangle, this is the hypotenuse. So C squared is going to equal the sum of the squares of the other two legs. So 14 squared plus 8 squared, doesn't matter what order you write those in. And so then if I keep going, 14 squared is 196, plus 8 squared is 64. Oops. I'm just trying to type this in my calculator as I talk. So 14 squared plus 8 squared is going to give me 260. So now to solve for C, you're going to be taking the square root. Now we're going to be learning in a little bit that when you take a square root, you should give two answers, but this is always going to be a positive answer. So you can ignore what I just said, but I always feel like I have to say it. So to solve for C, we're going to do the opposite of squaring, which is the square root. So we're going to take the square root of 260. Now this is a great answer. If I plug in the square root of 260 into my calculator, I get an irrational number, which I wouldn't want to use in a further calculation. So I would keep this as root 260, and yet if I was using this in a further calculation, you also want to keep those as simplified as possible. So we're going to simplify this radical. So we're looking for the highest perfect square that divides evenly into 260. I'm going to start with, so I know 121 won't work, I know 100 won't work, so I'll try 81. Doesn't work, so 260 divided by, I can't go backwards in my head, 64. 260 divided by 49. 260 divided by 25. 260 divided by 16. 260 divided by 4. Maybe I should have started that way. So the highest perfect square that goes into 260 is 4. So in my first radical, I'm going to put a 4. 4 times 65 is 260. So then simplified would give me 2 root 65. So now if I had to use this number in a further calculation, it's in its exact form. So pause the video, give this one a try. The key difference here is that instead of solving with hypotenuse, we're solving for a leg. So you have two choices. You can set this up as 6 squared is equal to b squared plus 4 squared. Or you could say that to solve for a leg, it's always the longest side, so the hypotenuse squared minus the other leg squared, which you'd get if you rearrange this equation as well. Wow, my b's and my 6's look the same. So if we plug this in, we get 36 minus 16, which is going to give me the square root, or 20. Now to solve for b, I'm going to take the square root of 20, and again, I want to simplify this. So the highest perfect square that goes into 20 is 4, the other factor would be 5, and the square root of 4 is 2. All right, another place that we could use this process of simplifying is in the distance formula. So the distance formula finds the distance between 2 points. So what it's saying is that if we have a point at -3, 2, and we have another point at 0, -4, and we want to find the distance between them, what they actually do is Pythagorean theorem. So the distance formula is Pythagorean theorem. It says what is the distance in y, what is the distance in x, and then you can find the length of the hypotenuse here. And so you'll notice in this formula here, they've already taken the square root. So d equals the square root of the sum of the squares of the other two sides. So I always like to write the literal formula first. So practicing, x2 minus x1 all squared plus y2 minus y1 all squared. And just like the slope formula, it doesn't matter which one's x2 and which one's x1. And just like the slope formula, it might help you to write the points on top of each other. -4. So now what we're going to do is subtract the x values. So we're finding this distance between the x's. So it's going to be -3 minus 0 all squared. Then we're going to find the distance in the y values. So it's from 2 to -4, so minus -4. all squared. So then plugging this in, you've got -3 squared is 9. You've got 2 plus 4 is 6 squared, which is 36. And that gives you the square root of 45. And again, great answer, just not simplified. So we want to simplify our radical. So the highest perfect square that goes into 45 is 9. And then the square root of 9 is 3. So the answer would be 3 times the square root of 5. So from now on, from this point in the course on, if you ever get a radical answer for any equation, you are expected always to simplify because you've learned the process of simplification.